is what we haven't gotten to yet is you could say the things when someone is creating, imagine if God was creating you as a person. It's not just things that you have, like how many legs or how many eyes or what your hair color is. It's also mostly about things that you can do. But let's take a look at this dog example. So, for example, one of the things that we haven't touched on is the example of methods. So, what we like to call class methods. So what these are methods are class-specific functions. These are functions that things that a dog can do that a human can't. So a dog will have class-specific functions. These functions can be called by specific objects, such as Bobby or Scruffy. Here, what we're basically saying um, is that all dogs can bark. Therefore, barking is a class method. We don't have to teach Bobby and Scruffy separately to bark. So the method bark is a is a class method. So every time there's a class method, we use def, and we do it inside of the class. So if the class is over here, class dog, we make sure that we indent one level deep, and then we begin writing our methods. So we've done this before, so we don't have to spend too much time on this, but just know def sort of means definition of what this method is. So then we write the name of the method. So the name of the method for me for this dog is bark, okay? So bark, like that. And we put a special self. Remember, self, we mean myself, my class. So I'm referring to myself here. So we have to refer to myself. That's just a special bit of magic code that we write here. And then we do the implementation. So we'll worry about how a dog barks. We don't really need to know that. We'll just write a little bit of a print statement for now. So anything in red, you can just imagine, or in this purple, it's how a dog barks. So for now, we'll just print. And once again, I'm indenting to show that this is the related to bark and not related to class in general. So I'm going to print woof. For now, that's how a dog barks. It just makes a sound. So this one is also indented. Every time you see an arrow, this means indentation. Okay, so this over here means indented. Okay, so let's go ahead and write this up in code. So here I'm going to go ahead, and we already have one definition. We cheated before. This is not the first one. The init is one that every class usually contains. Everything else is up to us. So if a dog is meant to bark, it will have this bark method. And we're going to print woof. Okay, we're going to print woof. So that's this method over here. We're saying every dog is able to bark. So now you can see, let's come down over here to where we defined a dog and where we told Python to create a variable called dog. We can now, without doing anything, without teaching Bobby how to bark, we could just say Bobby.bark. Because it's a method, we have to put open and close parentheses, okay? And do the same thing here with Scruffy. Scruffy.bark. And now you're going to see two barks come in at the end here. Woof and woof. So how do they both know how to do that? Well, that's the magic of classes. Once we declare it in the class, every single time someone else, so let's say we create a new dog over here. We create a new dog as represented by this circle with a B. We create a new dog called Bobby. Bobby, if we tell it to bark by saying dot bark, and if we create another dog that is Scruffy, we can also tell Scruffy to bark. They both will know how to do it because Python will look at who they are. And we know that both Scruffy and Bobby are dogs. And Python will go to the dog and will search for all of the dogs methods. It's searching for a method and not a property. It's not searching for legs, for example. Legs are still over here. We still have legs defined here, right? As usual, legs is equals to 4. But because we have these two open and closed parens, Python is looking specifically for a method. And it looks at this class and it says, okay, well, I have this method over here called bark. So I'm going to do whatever it says. I'm going to print woof. And over here, that's how you get it printed. Okay. So that is how we do that. We have our two dogs barking. Okay, so let's create another fun method. Let's create a method called greet that's also going to take in the necessary self, as always. And greet is going to be a method that introduces the dog to itself. So this way, a class knows what the name of itself is. So once you create a new object and you say that the object's name is Bobby, within the class over here, we can use that name. So for example, let's have a function called greet. And because we know what I am, that's what self is, it refers to myself, I can print out this message. I can say, hello, my name is, and then I'll say plus self.name, and then plus, and I am, and I'll say plus str self.age plus years old. Okay, so hello, my name is self.name, and I am so-and-so years old. So let's take a look at this method inside of our Sketchpad here. Okay, I'm gonna get rid of all of this. And let's take a look at our method here. So this is our greet method. All that happens, right? There's really nothing magic going on. All this means, this fancy self.name stuff, is that every time we see self.name or self.whatever, age, self.name, self.age, we look at what this class is. And this class is a dog, okay? And it has in its init method something 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 self.name. And when we create this class, we do this. We say to create the class, we give it a name and an age by doing this. So when we create a class here, we give it a name and an age, right? This is the name. This is the name, and this is the age. So when I'm printing out this greet method, I just replace self.name, I cross it out, and I replace it with Bobby. Okay, so it's going to be Bobby. We'll run this program to make sure, but this is what we're assuming is going to happen. And once again, we erase self.age. Every time we see self, we erase it and we get the age that was defined and we replace it with 12. So let's see if this works, okay? So we're going to go in here and we're going to go in here and print greet. So I'm going to say Bobby.greet and Scruffy.greet. And let's see what the two dogs say. Hello, my name is Scruffy, and hello, my name is Bobby, and I'm 12 years old. Hello, my name is Scruffy, and I'm 7 years old. So the two dogs are able to talk about each other's themselves. So that was something that we wanted to know for sure. Okay, so the other thing that we want to talk about is, remember that some people like to think of this as a car factory. So I want to talk about this. Like, let's get rid of the dog example, and let's take a look at another example, is something that we all know, which is cars. Imagine a car factory that builds cars, right? Imagine a car factory that builds cars. And each car is pretty much identical to one another, but they are, of course, some key differences. Some people like yellow cars, some people like green cars, some people like red cars, and of course, some cars look quite different and behave quite different, and they have different speeds and so on and so forth. But a car factory can create many different types of cars. And in Python, when we can create a car factory using something called a class. And this class is going to serve as a blueprint for creating individual car objects. And what we mean by that is picture a large sheet of paper that contains all the details of the specifications to build a car. We can call this the specs, okay? And these are the specs that are needed to build our car. That's our class. It tells us what attributes a car should have, such as color, make, maximum speed. This one could maybe go 250, while this car might only be able to go 150 miles an hour, and so on and so forth. But it's all listed in this spec. And this spec over here, this is the most important part. This is the spec that goes into every single one of these cars. Okay, so that is the important part that we want to realize. Now, the car factory, which is our class in Python, okay, let's go and create another replit here. The car factory, which is our class, uses this blueprint to create an individual car object. So if we have a class of car, and remember we create a magic function called init, it creates a car with a make, a speed, and a color. And of course we say these magic words, self.make equals make, and self.speed equals to speed. Okay, so now we've set up our car here. It has these different attributes. So let's bring it down into our sketchpad here really quickly. And we've got this car, right? Over here, we've got this car, and it has the different colors. So you can have a car that's this color, this one. So these are the colors, right? These ones or this one. You could have different speeds here. So the speed could be here. And of course, even the looks, they're all different. So maybe this is a Honda, this could be a Porsche, and this could be something like a Hyundai, okay? Or whatever. Nissan, whatever cars you want. So in the next steps, what we do is we use this blueprint to create individual cars. So we use this small blueprint that we've created over here. We use this blueprint to create a car. And it's essentially just that simple, right? So we can have a car like this. So we can create a car. We can call it my car, and it creates a brand new car. And we set the color, we set the make, and we set the speed like that. And once we're satisfied, we have a new car. Um, Now here we've created a red Toyota that can go up to 120. And so we've created this car here, okay? So we've gone ahead and created this car, this red one, okay? So let's just say we've created a red car, and it's going to be a Porsche, okay? So it's going to be a Porsche and a Porsche, and it goes up to very fast, let's say 350 miles an hour, and it's a red car, okay? So this car is an individual car, but it can also have different methods. For example, it can accelerate. So how about we want to lift off or take off? So we're going to say diff def accelerate self. So we've created an accelerate function. So maybe this accelerate, it increases the speed. So the speed of this car is now going up by 10. Um, that doesn't really make sense because here we've said the speed is the top speed. So an accelerate wouldn't necessarily increase this top speed, but you know what I mean. For example, maybe instead of accelerate, we could just print uh, zoom, zoom, zoom. Okay, so now my car will accelerate, and when I put the pedal down, it will say zoom, zoom over here on the screen. So hopefully that gives you a little bit of an illustration of how classes work and how they relate to car factories and dogs and all that stuff. Yeah, thank you for coming along with me.